Hello and welcome to Nkuma's Online Academy. Today we have a set and we want to talk about subset and proper sets. Subsets and proper sets. A subset is a set that is or that all its elements are parts of another set. For instance, if you have two sets A and B, and in A we have a set of integers, a set of positive integers. You know that integers include 1, 2, 3, 4, 5, 6 to infinity. Now, if we have another set B whose elements are even numbers, now it means that all the elements in set B will be included in set A because integers contain both even numbers and odd numbers. So all the elements you can see in B, you can also get them from A. So B is therefore said to be a subset of A. Now the one that contains the elements in the subsets, that set is called the superset. Therefore, A is a superset of B and B is a subset of A. So if one is a subset, now the other one is superset. I hope this is clear. Now for proper set. Proper set is somehow related to subset, the concept of subsets. But in proper set, if you have A and B as two sets, and B is said to be a proper set of A, it means that in the superset, there are elements in the superset that are not in the subset. There are elements in the superset that are not in the subset. For instance, the example we gave before, if A is a subset of integers, if A is a set of integers and B is a set of even numbers, of course we know that the integers contain odd number and even numbers. Then if B is only the even numbers, it means that it will contain only some part of the elements in A. That is only the even numbers, while the odd numbers will be left out. That is said to be, the B is now said to be a proper set of A because there are elements in B, there are elements in B that there are elements in A that are not in B. There are elements in A that are not in B. So that is what we call a proper set. When we have some elements in the parent set, the parent set is the superset. Now that are not in the subset. If the subset is equal to the element in the subset is equal to the element in the superset, we say that the sets are equal. If the element in the superset is equal to the element in the subset, we say that the sets are equal. So there's a relationship between superset, subset, proper set, and equal sets, and it should be well noted. In equal sets, the superset and the subsets are equal, or the parent sets and the child sets, they are equal. In proper sets, the parent set or the superset contains elements that are not in the subsets. Okay, let's give some examples. If assuming we have this a is equal to 1, a is equal to, let me say, 1, 2, 3, 4, 5, and b is equal to 2, 4. Now what it means now is that since we can find all the elements in A, we say that B is a subset of A. We have 2 here, we have 3 here. So all the elements in B are in A. So B is a subset of A. A is said to be the parent set or the superset, while B is said to be the child set or the subset. Now also, because we have 5, we have 4, we have 1 here, and they are not in B, then we say that this is a proper subset. A proper subset. Because there are elements in B, there are elements in A that are not in B. This makes it a proper subset. Now, if all the elements in B are in A, assuming that B is equal to assuming that B is also 1, 2, 3, 4, 5, 6. Now we see that all the elements in A are also in B. Now that makes B an equal set with A. It makes B an equal set with B. I said that a proper subset is a subset in which the parent set contains some elements that are not in the subset. While in equal sets, all the elements in the two sets are equal. I think this is very clear. We can give some other examples. If we have A, let's say that we have A as a set of, we have A equals integers. A is equal to integers. Integers, we can have positive integers, we can have negative integers. So, and it is not possible for us to count all the elements in A because we cannot count all the integers. So we start from infinity and go to infinity, negative infinity, negative infinity, and then we go to positive infinity. So we can count to the number that we can count, like 1, 2, 3. Now we use infinity sign to show that it continues. So this side is now positive infinity. No need of writing positive, but for this side, you have to show that it is negative. Now, B, assuming that our B is a set of a set of even numbers. A set of even numbers. An even number can be positive or negative. Therefore, we cannot count all the even numbers. So we start from negative infinity to the ones we can count. We have 2, we have 4, we have 6, and then we continue to infinity. Now, this, how can we